Hey there, CJ Math students. I'm going to help you out with homework 9.7, probability. I know we didn't cover this today because we spent a little bit more time on the MMR stations and statistics, but probability is something that you have seen on ST Math, and it's super simple to grasp. So basically, I want you to write this off to the side here. Probability, P-R-O-B, probability, is basically equal to what you want over the amount of total choices you have. All right, so what you want over the amount of total choices you have. So take a look at, let's say, number 1. You want the probability of picking C. So what you want is C, and there's one C. All right, over how many total letters do you have? 1, 2, 3, 4, 5, 6. You have 6 total letters, right? So again, 1 was what I wanted, which is there's only one C, and 6 was the total letters. All right, so my answer is B, 1/6. All right, take a look at 3. What is the probability of not choosing D? All right, so what I want is not to choose D. So I can choose A, B, C, E, F. So I have 5 choices or 5 letters that are not D. And I still have the same 6 total choices, so 6 letters. So 5 letters that were not D, and 6 letters total choice. So again, my answer is B, 5, 6. That's my probability. I want to take a look at this question. I guess we'll call it 8 by default. But a store is handling coupons worth 10%, 15%, 20%, and 25% off. So 4 different types of coupons. Each coupon is equally likely to be handed out. Which of the following models could be used to simulate this situation? So basically I have those 4 discounts in my hand, and I randomly give you one. Which one of these simulations would represent me randomly giving you one? Well, flipping a coin 4 times, the coin only has 2 sides. So this is not going to work because I have 4 options. So F is not going to work. Spinning a spinner with 4 equal sections. Well, I have 4 options and they were equally divided. So yes, that is definitely going to work. So G is going to be our answer. Rolling a cube labeled 1 through 6 one time. Well, again, this has 6 options where I just want 4 options, and rolling a cube labeled 1 through 6 4 times. Again, it seems attractive because it says 4 times, you got 4 options, but again, 1 through 6 has 6 sides or 6 options. So it's definitely G is your answer. Let's help you out with number 9. What is the experimental probability of tossing tails? So first of all, there's a difference here. There's in theory, and then there's experiment. So in theory is if I were to flip a coin, 50% of the time it should get heads, and 50% of the time it should get tails. So, right, in theory, heads and tails, I should get 5 heads and 5 tails because you have a 50-50 shot of flipping it, right? If I actually flip a coin 10 times, I'll probably get numbers way different, right? So this is actually doing it. All right, so let's think. What is the experimental probability of tossing tails? So if I have these results, Bailey tossed a coin 10 times, in theory I should get 5 tails, but the results were 7 heads and 3 tails. So of tossing tails, I wanted to toss tails. I did that 3 times. In total, I tossed it 10 times, so 3 out of 10. B is your answer for 9. All right, take a look at number 10 in comparison to number 9 because it says the theoretical probability of tossing heads. In this experiment, the theoretical probability was 7 over 10, right? Because they got 7 heads out of 10 tosses. And it should have been sorry, my fault, I've totally messed that up. The experimental probability was 7 over 10, and it should have been 5 over 10. So you use that information to help you answer number 10. Number 11, Micah and Joan are on the same softball team. Micah got 8 hits out of 48 times at bats, while Joan got 12 hits out of 40 times at bat. Who do you think is more likely to get a hit her next time at bat? Well, let's take a look at Micah. So basically, we're just going to compare these two ratios or fractions. So we're comparing Micah, which is at 8 out of 48, versus Joan, which is at 12 out of 40. So we've done this before. This gives you 320. This gives you 576. So we point to the smaller one. Obviously, we like Joan because her ratio is higher than Micah's. You could also just use your fancy calculator and do 8 divided by 48 and get 0.166 and compare that to 12 divided by 40, which gives you 0.3 or 300, right? And it still turns out that Joan is better. So you would say, I expect Joan to get hit because currently her hit to at-bat ratio is greater than Micah. Okay, all right. Number 12 is an error. Talia tossed Penny many times. She got 40 heads and 60 tails. She said the experimental probability of getting heads, right? She got 40 heads, was 40 over 60. That's incorrect. You got to explain the error. So again, it's all about, she's saying that it's 40 out of 60 because she got 40 heads when she tossed the coin and 60 tails. That's incorrect. You got to explain why it's incorrect. All right. So before we begin this backside, there's a couple of things that you want to remember. For months in a year, there are 12 months total, so 12 total. For cards, it's a little bit different. So 52 is your total, so 52 total, and then there's a whole set of breakdowns. If you don't know cards, I'm going to try and help you out here. So within cards, you have 13 clubs, 13 spades, I'll do these in red, 13 hearts, and 13 diamonds. And so those all represent 1/4, right, of 52. So like literally the fraction 13 over 52 can be simplified down to 1/4. So that's for your reference later on. And then also you have four kings, 2 black, 2 red, right? So 1 club, 1 spade, 1 heart, 1 diamond. You have 4 queens, again, 2 black, 2 red. You have 4 jacks, again, 2 black, 2 red. And you have 4 aces, again, 2 black, 2 red. Okay, so that's just in case you didn't have that background for a deck of cards. That should be able to help you solve some of the card problems. All right, so let's take a look at finding the probability of selecting March. So here's how I want you to kind of show work for this. So probability you can just label as P. So P is equal to what you want. There's only one March out there. And over your total choices. So there are 12, 12, we'll call them months, right? So your probability is 1 over 12. I'm going to kind of zigzag my way down here. Find the probability of drawing a white queen. Well, let's take a look at this. Is any such thing as a white queen? Well, queens, they're either black or red. So my choices are 0 white queens, because they're either black or red. And I have 52 total cards, right? So my probability is equal to 0 over 52, otherwise known as 0. It is impossible for me to get a white queen. Find the probability of selecting a month that starts with either M or J. So let's think about that. We have March, May, June, July, and January, right? So that's 5 months out of, again, 12 total months. So, oops, that's not months, but months. And so that gives us a probability of 5 over 12. And what's the probability of drawing a heart? So if you go back up to here and see, okay, there are 13 hearts in a deck of 52 cards. You'd say, all right, I got 13 possible hearts. and 52 possible cards. And hopefully you recognize that little tip I gave you early on that, 13 out of 52 is 1/4. And so yeah, my probability isn't 13 over 52, but I can divide both these by 13 and get 1/4. So my probability is 1/4. Always simplify your probability, right? And then this last one, find the probability of selecting a month with 30 days. So this is a little bit tricky. You could look at a calendar and ask yourself, all right, what are the months of days? Like go down to the bottom here. The months that have 30 days are April, June, September, and November. So only 4 months. So 4 out of 12 possible months. So again, that gives you a fraction of 4/12, which you can obviously simplify down to 1/3. All right, and there you go. Call me if you have questions.